Hey everyone, welcome again. I'm back with another topic on BJT, that is Bipolar Junction Transistor. It is a three-terminal device and it can be classified as NPN and PNP. So here you can see this diagram is for NPN type of transistor, and what does this NPN signifies? It signifies the type of doping in that region. Like I said, it has three terminals, that is emitter, base and collector. So the type of doping in these three regions gives it a name as either NPN or PNP. Here you can see that emitter is N-type doped, that is it has pentavalent impurities. Base it has trivalent impurities in it, and finally the collector is again N-type doped. Now from the name itself, it suggests that emitter will emit something. What does it emit? Since it is N-type doped, so this means it has electrons in excess. So it will emit electron, and collector will collect those electrons. Base is kept as thin as possible in order to maximize the transfer of electron from emitter to collector. If we talk for doping type, doping concentration, so you should note this, that emitter is heavily doped. Why heavily doped? Because it needs to emit more number of electrons. Base is very lightly doped, very lightly. Why its doping is kept very low? Because we know that base has p type of doping. This means it has holes as majority charge carriers. So as the electron from emitter will try to pass towards collector, so we need very less number of electron to get recombined with the holes, and maximum electron is required to pass towards collector. And if we talk about area wise, then collector has the greatest area. Why greatest? Because it collects large number of electron. Base is thinnest of all because of the reason I already told you, and emitter is in between. It has moderate size. So these two are the important parameters which you need to know from the construction point of view. Now you can see this diagram which shows two PN diode connected back to back. What does this signify? If you look carefully in this diagram of BJT, then here there are two junctions, junction 1 and junction 2. Okay, so if you see that one junction is between N and P and other junction is between again P and N, so can you look at like two diodes connected, one NP and one PN, but does it work similarly? No, because here you see that these two diodes are not at all connected. They does not affect each other, but it is not the case in BJT. This P and NP region will definitely have influence on this PN region. This complete functions as one. It does not function as two diode connected. This is the symbol for NPN type of transistor, collector N type, base P type and emitter N type. Now what does this arrow signifies? This arrow shows the direction of current from base to emitter. So in NPN type of transistor, the current will flow from base towards emitter. Now we have already talked about NPN transistor. Similarly, you can apply all those things to PNP also, but only everything is reversed. Here emitter is connected to P type, base is N type, and collector is again P type. Here the connection of diode, the similarity which is being shown is also reversed, and again here also you can see the direction of this arrow is reversed here again. Now the current is flowing from emitter to base. What are the current component? Let me just this is PNP and this is NPN type of transistor. So if you see this, like I told you that this arrow shows the direction of current, and in this PNP type of and also in NPN type transistor, you can see that emitter current is being divided into base and collector. Similarly for NPN, these two, base current and collector current, they combine to form emitter current. From these two, we can conclude that this relation holds true. That is, I emitter current is equal to the sum of collector and base current. So this holds true for both PNP and NPN type of transistor. Now this flow of current, direction of current, this you will get to know more clearly in the working of BJT, but for now this condition holds true for both the type of transistor. Now BJT works in three regions of operation: that active region, saturation region and cutoff region. These three regions you can see in this characteristic curve, which is being plotted between collector current and collector to emitter voltage. So this first region, this yellow portion, is the saturation region. This center portion is active region, and this below portion where current is very less, this region is cutoff region. BJT works as an amplifier in active region, and it acts as a switch in these two regions, saturation and cutoff region. How? In saturation region, transistor is completely on, and in cutoff region it is completely off. So combinedly in these two regions, a transistor works as a switch. And if we want to use it as an amplifier, then we will have to use it in active region. Now what these three regions are and how can we obtain these three type of region in a single BJT, this we will see now. So this is first one is active region. This is the NPN type of transistor. Now this is emitter and this is base. So this voltage is VEB and this voltage is VCB. Okay. Now in what happens in active region, this voltage is forward biased, this region, and this collector base region is reverse biased. Now here how it is forward biased, because this N region, emitter N region, is connected to negative terminal, and the base, that which is P type, is connected to positive terminal. So that's why this is forward biased. Here again the collector, which is N type doped, is connected to positive terminal, and base region, which is P type doped, is connected to negative terminal. So that's why this is reversed bias. So when this type of biasing is done in both these two regions, then the BJT will start operating in active region and it will start behave as an amplifier. Now in saturation region, again this is VEB and this is VCB. In saturation region, both these region are forward biased. You can see that negative is connected to negative terminal, N type is connected to negative terminal, and P type base is connected to positive terminal. Here also N type collector is connected to negative terminal and P type base is connected to positive terminal. So when these two regions are forward biased, so it start working in saturation region. In cutoff region, VEB, VCB. In cutoff region, these both are reverse biased. So in reverse biased, N type connected to positive terminal, P type base connected to negative terminal. So reverse biasing. N type collector is connected to positive terminal and P type base is connected to negative terminal. Again reverse biasing. So because of the difference in these three type of biasing, we can change the region of operation of BJT and we can obtain according to the application we require. You can see here what these three regions are and how the biasing is done in these two junctions. Sorry, this is reverse biased. And the application they can be used in these three type of region. Now these can be configured as follows: common emitter, common collector, common base. Common word signifies that what terminal is being taken as reference. This means in common emitter terminal will be common to both base and collector. Similarly for common collector and common base. Like I told you, common emitter, this emitter terminal is common for both base and collector. So this side works as input and this portion act as output. This common collector. So here collector is being taken common to both base and emitter. So here this region is being taken as input and this is output. Again for common base is common to emitter and collector both, and this portion is input and this is output. Hope you understand all the three type of configuration and the region of operation of BJT. Now let us talk about its actual working. Okay, so if you see this diagram, from there you can see that I have taken base common here. Base is being taken as the reference terminal. So this is common base type of configuration. And if you look into biasing, then you see that this N type emitter is connected to negative terminal, P type base is connected to positive terminal. So this makes this a junction as forward biased. And if you see here this side, then this N type N doped collector is connected to positive terminal and P doped base is connected to negative terminal. So this makes this junction as reverse biased. So what does this mean? Here this is being used as an amplifier. So you are going to understand the working of BJT as an amplifier. So how does it work? You see that this is negative terminal. This emitter is connected to negative terminal. So because here electrons are present here, so this negative terminal will start pushing the electron towards base region. Some electrons will easily pass through base due to presence of holes here. Some electrons will get recombined, other electron will pass this area. Now you see that this base is connected to positive terminal, so some electron will also be influenced by this terminal and will start flowing this side. Okay, and rest electron will get collected at this collector terminal. So if you carefully look, then the electrons are being moving this way towards collector and this way towards base, collector and base, and they were coming from here emitter. So if you carefully look, that the electron from emitter being emitted by emitter are divided in towards base and collector. Now we know that conventional current direction is opposite to that of flow of electron. So what will be the direction of these three type of current? Collector current will move this side, IC, base current will move this side, IB, and emitter current direction will be this. So now can you relate the direction which we saw in the previous slide? From here you can see that this IC plus IB is giving IE, and this relation we have already seen. So from here you can conclude that emitter current is the combination of collector and base current. Now some relation which hold true are IC equal to beta IB, IC equal to alpha IE, and IE equal to 1 plus beta common emitter amplification by factor. Alpha is common base amplification factor, and 1 plus beta we call it as gamma IB is common collector amplification factor. So this beta comes in range of 50 to 400, and alpha is alpha is less than 1. So from all these relation, can you see that output current is being influenced by input current? So can we say that BJT is a current control device? So that's all. Hope you like it, and if you do, please like and subscribe. Thank you everyone. Bye to all.